So, in the previous experiment I have shown you how one can do the estimation of chloride and HCl and ammonium chloride in a mixture of ammonium chloride, HCl and potassium chloride using NaOH. So, now this is the second part of that experiment where we are going to estimate the concentration of total chloride in this mixture, which we call as a triple mixture of 3 different chlorides. So, we will estimate the concentration of chloride in this triple mixture using the primary standard that we have prepared is a standard silver nitrate solution. So, as you all know that when we add silver nitrate to a solution of chloride, a cardi white precipitate forms. So, you will see the same phenomena happening here. So, at the moment what we have taken in the beaker here is just some amount of water, distilled water, and you can see the conductance of that distilled water is shown here. It is about 8 microsiemens, 8.72 microsiemens. So, now I am going to pipette out this triple mixture and add it to this water for the estimation. As soon as I start adding this solution, you will see that the conductance of the solution is changing. It will be increasing, so it will take a while for the instrument to stabilize and equilibrate to the correct conductance of the solution, which is a solution of triple mixture. So, before starting the experiment, we should mix well and homogenize the solution so that it gives the correct reading for the conductance at the beginning. So, with 0 volume of silver nitrate, we need to take the reading of the conductance, and we see the conductance is coming around 853.5 microsiemens. So, now you can see that I have a slightly different burette, but it is again a 10 ml burette graduated. You can see it is 10 ml graduated burette, and I have filled this burette with the standard silver nitrate solution. So, from this I will start adding silver nitrate dropwise to my analyte solution in the beaker, and you will see a cardi white precipitate forms when we add first time, and further addition will continue increasing in that cardi white precipitate, but then you will not be able to see the difference so much, because after addition we will have to shake it and that precipitate will be homogenized as a suspended particle in the solution. So, now I am going to add this silver nitrate to this solution. So, I will be adding very small amounts like 0.04 ml each time. You can see that with 1 drop of silver nitrate, the solution has become cardi white, right? A faint precipitate has formed. It is no longer a clear solution. and that is because of the formation of silver chloride as precipitate. So with 0.04 ml of silver nitrate, you see the reading is not changing. The conductivity value of this solution is not changing here at all. Why the conductivity is not changing? Because the reaction what is happening here is consumption of chloride ion by silver nitrate. So, chloride ion is removed as a silver chloride precipitate and is replaced by nitrate ion, which has very similar conductivity compared to chloride, and hence we will not see any significant change in conductance till we reach the close to the end point. Beyond the end point, when we add, we will see that the conductance is increasing significantly because of more and more silver chloride is added. So, in this particular titration, we can use a larger volume gap between the two consecutive readings, because from the theory we know that there will not be any change in the beginning and there will be a change only when we have reached the equivalence point. So, now I have reached a point of 1.1 ml, and I should mix well so that the solution is homogenized. We will see that little more precipitate has formed and the solution is becoming more non-transparent with time, but the conductance value is not changing at all. It still remains 852.2. This indicates that our experiment is going in the right direction. So, now I am going to add up to 0.25 ml. So, with 0.25 ml, you can see further silver chloride formation, which makes the solution more turbid. And now we see a slight reduction in conductance, 842.9, which is okay, I think. So, we will now keep on adding 0.25 ml each time and take the reading. So, now we have reached 0.5 ml and the reading is slightly reduced, but then again it will equilibrate and give you approximately the same value. As you know, the conductance of chloride and nitrate is about the same. It is not exactly same, and that is why we are seeing a slight gradual decrease. So, it is 842.6. We will add another portion of this bullet is different. So, I will add a 0.25 ml again. So with more amount of silver nitrate added, you see the solution is becoming more and more turbid, white precipitate is forming, and we should remember that this white precipitate can get deposited on the electrode. So we have to do this titration very quickly, and as soon as the titration is over, we have to clean the electrode. So we have reached a point when we have added 0.75 ml of silver nitrate, and we are getting the conductance of 834, 835.2 maybe. We just wait for a while. 835.2. We will add one more portion of 0.25 ml. See, compared to the previous experiments of both potentiometry and conductometry, here our step size is more because we are in a region where we are expecting a flat straight line, nearly flat straight line, where the conductance is not decreasing significantly. You see that we have already added 1 ml of silver nitrate, and the conductance that is now showing here in the conductivity cell, it is 829. So from 0 to 1 ml, which is now very close to the equivalence point, the decrease in conductance has taken place from 853 to 829. So with 1 ml addition, the change is very small. If you go back to the previous video, you will see that on addition from 0 to 0.5, 0.5 to 1, there were significant changes in the conductance values, and that is why we had to follow the steps of 0.02 or 0.04 ml. But in this case, since the variation is not so much, we can have a larger gap between the two consecutive readings. So now I am guessing that we are very close to the neutralization or equivalence point, and after another 1 or 2 readings we will start seeing that the conductance value increases, and then we will take a call at what point one should stop the addition. So now I have added one more portion of 0.25 ml and going to start. You should be seeing the reading, which is now showing stabilizing and then again giving you the value. We need to homogenize for a while and wait. Now you see, as I was expecting, there is an increase in conductance. The conductance has increased to 884.6. It is still increasing. Maybe it will stabilize at around 885 or slightly more than that, which essentially indicates the precipitation titration has ended. The equivalence point has been reached, crossed. So we will take this reading as 885, where we see the first increase in conductance. Now we will keep on adding 0.25 ml as before and take the drop in solution, mix well, shake well. So now what is happening is all the chloride ions are consumed. Whatever we are adding AgNO3, and the conductance increase is corresponding to the amount of silver plus and nitrate ions that are added on top of whatever ions were present in this solution from the very beginning. So you see that it has increased to 978, 900 maybe 79, so 1.5 ml, it is 978.6. So it is in the increasing trend. We will need 2 or 3 more readings so that we should be able to plot a nice straight line after the equivalence. Before the equivalence we have so many points, so with those we will be able to plot a straight line. After the equivalence also we will need at least 5-6 points to draw a best fit straight line. We have reached 1.75 ml, and you see now it has jumped from microsiemens to the region of millisiemens. So we should write it again in terms of microsiemens. So 1.073 millisiemens means 1073 microsiemens. We will take one more reading with 2 ml. And we see that this is coming out to be 1155 millisiemens, microsiemens. So now if you see beyond about 1 ml, which is just after the equivalence point, the conductance was increasing. After 1 ml it is 1.25 is 85, from 885 to 978 is about 90, 978 to about 1073 is again about 80. So this constant increase 80 to 90 millisiemens, 80 to 90 microsiemens indicates that we have got 3 or 4 points which are after the equivalence point, and we will just for the safety purpose we will take one more reading with another addition of 0.25, so we have 2.25. Because at the end when we try to plot we should not be falling short of the number of points. 1 point or 2 points may go out of the straight line, so we would need about 4 to 5 points to draw a best fit straight line. So with 2.25 it will stabilize and give us the reading in a while. You see now the response has become slow, and that is simply because of a lot of silver chloride that is forming, and it is probably getting deposited on the electrode, and that is why it is a bit slow in giving us the conductance value. So it is 1233. So we will stop at this point. Very quickly we should remove the burette, we should take it away and carefully lift up the electrode, remove the solution and throw it away. We take a separate beaker first to quickly wash the electrode with distilled water, and you know that distilled water is not enough, it cannot dissolve silver chloride which may have got deposited in this electrode. So we should use a dilute solution. So we should use a dilute solution of ammonium hydroxide which dissolves the precipitate of silver chloride and it will remove it from the electrode. We should be careful while using ammonium hydroxide. We should not smell it, as you know it has a pungent smell. We are using a very dilute solution of ammonium hydroxide to dissolve any precipitate that may be there sticking to the wall of the electrode. We should clean the electrode surface as well 2 to 3 times with this ammonia solution. Now we should wash this electrode thoroughly with water and remove all ammonium chloride or ammonium hydroxide that may be here. This is a very important part of this experiment, that you should wash the electrode carefully so that you don't leave any silver chloride as deposited particles on the electrode, which will then cause problem in the next set of experiments which we do or somebody else would do. Whether the electrode is now clean or not, one can see it by dipping it in distilled water. If the electrode is nice and clean, we should get the starting conductance value, which we already noted that it was about 8 microsiemens. So what we see here is that the conductance is much higher. It is about 200-300 microsiemens. That essentially means the electrode is not fully clean yet. So we need to wash the electrode several times and discard that water. Use more water to clean. And keep an eye on the conductance value that it is showing. See, now it has reduced to about 16 to 20 microsiemens and still stabilizing, which means it is getting cleaned. Maybe one more round of cleaning with water jet, it will be completely clean and we will see a reduction in conductance to about 8 microsiemens, 8 to 9 microsiemens. You see, now we have reached about 10, which is a reasonable number. Maybe 1 or 2 more rounds of cleaning will reduce the conductance to 8 from where we actually started. So I think this is a point where we need to leave, because it's reading about 8 to 9, 10, it is all right. One can take this electrode to the lab and dip it in little more of ammonium hydroxide solution and remove. But in my opinion, if it is about 8 to 9, then I think it is fine. So we have completed the experiment of triple mixture. We have done 2 titrations, once with sodium hydroxide and once with silver nitrate, and we have got the set of readings. So in the next class, I will discuss about these readings, how to plot and what would be the result of these experiments. So we will continue from here in the next theory class. Thank you.